Hello and welcome as we continue talking about limits. We're talking numeric and graphical approaches. And in the last video, we ended with this question. We have our predicted value and it equals the actual value. Then shouldn't we just use the actual value from the function? And we're going to go ahead and talk about that in this video. So there's the question, is evaluating a limit at a certain x value always the same as evaluating the function? Will they always be the same answer? So again, in this video, we're going to start with exploration first. We're going to experience the problem, and then we're going to come back and formalize it with some notes and some math notation. So on this next page, you will do problems 4, 5, and 6 by just looking at the graphs and answering the questions that go with them. So take a moment, pause the video, and answer the questions on this page. Now, let's go ahead and go over these answers, and then we're going to put some math notation with them. The first question says to match the function to its graph, and you'll see that probably the easiest one to identify is this first one, h of x, because it'll be this middle graph. It's just a nice smooth curve with no piecewise or any other functions with it. The next one we might identify here is g of x. We have two separate functions. We see that in the first part of the function, it is following that same path of h of x. It's that same function until you get to 0.5. And then the second part of this equation is going to be a line. And finally, this piecewise function is very interesting because we have that same function that we started with for the other two problems with a nice smooth curve, except for we have one little thing here, and that is at 0.5, we have a hole up here as identified by the x cannot equal 0.5, and the value at 0.5 is going to be 8. All right, we've identified all those functions. Now let's look here at some of these questions. For question 5, we're looking at f of x. So this is going to be this last graph over here. And it says, what y value is being approached as x gets closer and closer to 0.5 as it's coming from the left? So what I'm looking at is, as I come in here from the left, I'm getting closer and closer, and it looks like we're getting very close to 15. And that is the answer we have. To write that mathematically, I'm going to say that we have the limit as x approaches 0.5 from the left of f of x. That's going to equal 15. Now let's look what is happening in question B. As we come in from the right, we notice that we're approaching that same value, that same output value. So this will be the limit as x approaches 0.5 from the right, and we use the positive sign to represent the right, of f of x is going to equal 15. Now, this says, can you make a good prediction? Well, the left matches the right, so we can say that the limit exists, and as x goes to 0.5 of f of x, this is going to equal 15, and that's because these two agree. So we can say that the limit is 15. But here's the interesting part. The limit for this function is 15. It is approaching 15 as we come in from each side. However, question D says, does the limit or does our prediction match the actual value? Well, if you go back to this function, the value at x equals 0.5 is going to be 8, and that's represented by this right here. So f of 0.5 is going to equal 8. The limit doesn't match the value of the function. The next question says, let's look at graph G. That's going to be this first one over here. Lots of interesting things going on. And this says, what is the y value approached as x gets closer to and closer to 0.5 coming from the left? All right, so I'm going to come from the left, and our y value is going to be 15. That's the output value. So this is the limit as x approaches 0.5 from the left. That's what that little subtraction or negative sign represents, of g of x. That's going to equal 15. Now, what happens when we come from the right? When I get closer and closer to 0.5, you'll see that my output is approaching 8. So the limit as x approaches 0.5 from the right of our function g of x, this is going to equal 8. One thing I did want to mention with piecewise functions is here we have a graph, and the graph is very clear what these values are. However, if we had something that was a little more messy to find these values, for example, to find the value for 15, I would just substitute this x value of 0.5 into the part of the equation that is less than 0.5. So that would be this part of the equation. And then to find this 8, I would do the same thing, except for you're doing it into the other part of the equation, this second branch here. All right, before we get to question C, the question is, what is the limit as x approaches 0.5 going to be? Well, these don't agree. 15 and 8 aren't the same. Since these don't agree, we would say the limit as x approaches 0.5 of g of x, this is going to be does not exist. It doesn't exist because the limit as x approaches 0.5 from the left does not equal the limit as x approaches 0.5 from the right. Another way we could say that is there is no clear intended value. Now, using this video and the previous video, let's put all these notes together in one concise spot. Now, using all the information that we learned in the last two problems, we're going to go ahead and put down some mathematical definitions and notations. And the first is the definition of what a limit is. A limit is the intended or predicted value of a function at a given x value. And as we saw in the previous page, the intended value or the predicted value may not match the actual value. In problem 5, we saw that the limit was 15 on the left and the right, but the actual value was 8. So it doesn't have to match the value of the function. Now let's go over the notation. We're going to write it as the limit, Lim, as x approaches a, and the a will be a value, or there's a chance it might also be infinity, of some function f of x, and that will equal L. So this will be x approaches a, and then this is the function, and then here this is the value of the limit. All right, then the other thing we saw is for our limit as x approaches a of f of x, it equals L if and only if the limit as x approaches a from the left equals the limit as x approaches a from the right. Those two have to be equal for the limit to exist. So both sides must match, otherwise we say it does not exist. Now, we need to have some strategies for evaluating these limits. First, we saw graphically that we can trace the graphs from the left and then also from the right. We also saw in the previous video that we had a table. So we can use this table of values near x equals a. Another method that we can use is if we have the formula, we can use direct substitution. This is where we plug the value into the function. We saw that with our piecewise function, where we plugged in these values in each branch of the function. We'll talk a little bit more about direct substitution in the next section, along with some algebraic skills to evaluate these functions. Now is your time to practice these problems. On the next 2.5 pages, there are some practice problems, and the answers are also up under this assignment for you to verify that you did them correctly. And then we'll move on to the next section where we talk about evaluating limits using direct substitution or algebra. See you then.